Welcome to One Line Watch. Today we are discussing about a topic which is related to plus 2 as well as BTech as well as degree and many more competitive level examinations. The titled as Differential Equations. Most of the students are not aware regarding the differential equations. Okay, now basically a equation which is having derivatives, differential coefficients are called a differential equation. So here d by dx, d square by dx square and so on, d to the power of n by dx to the power of n are called differential coefficients. Here x is the independent variable, sometimes we have to use dy by dx and sometimes d square y by dx square, whatever it may be. So a equation which is involving differential coefficients is called a differential equation. So means simply the definition of differential equation is defined as an equation whose having the differential coefficients are called differential equations. So further, differential equations are classified into two types. First one is ordinary differential equation and second one is partial differential equation. So in our next class we will discuss about briefly regarding the partial differential equation. Now we are discussing about the ordinary differential equation only. So in this ordinary differential equation, before we are going to simplification, first we have to know the knowledge of degree of a differential equation as well as order of a differential equation. So what is how we will define the degree of a differential equation and order of a differential equation. So before we define these two definitions, degree of a differential equation and order of a differential equation, everyone must be aware the order of a differential coefficient. For example, just now d by dx. So d by dx means it is a differential coefficient and its order is only 1 because of the derivative. If you have to take a function here f of x, then we can say that d by dx means f of x is a function, we did the derivative with respect to x only, means that okay nama d by dx of f of x. So means that this is first order differential coefficient. Similarly, this is for second order differential coefficient. This is third order differential coefficient. And similarly, this is nth order differential coefficient. So once we will learning about the order of a differential coefficient, now we are moving for the order of a differential equation. So simply I can give a simple example which gives that a differential equation, for example d square y by dx square plus 2 into dy by dx plus 3y equals to 0. Before actual how we can call this is a differential equation, because of it is equation and having differential coefficient. So we will call it as a differential equation. And now in this differential coefficient we are having two differential coefficients. One is first order differential coefficient and second one is second order differential coefficient. If we are going to second order if this is second order differential coefficient, so now finally we can define the degree of a differential coefficient is the highest differential coefficient in this given differential equation is called differential order of the differential equation. So means that the differential given example differential equation order is what, Nana? 2. Now we are moving for example number 2, sir. If you have to go through this example number 2, d cube y by dx cube plus sin x into dy by dx is equal to cos x into y. So I can take an example of a differential equation which is involving trigonometric ratios. If the differential equation which is having even the trigonometric ratios or a exponential or a logarithm, whatever it may be, the degree of a differential equation is defined simply as the derivative differential coefficient which is involving into the different equation is called its derivative, differential order of a differential equation. Now for this example, if you have to see this is the third order differential coefficient and this is first order differential coefficient. Here the order is 3, here the order is 1, more is 3. So simply we define that this is an ordinary differential equation and its order is what? 3. So now once we can define the order of a differential equation, after that only we can define the degree of a differential equation. Before that we couldn't find the degree of a differential equation, because of we have to first find order of a differential equation, after that only we can define the degree of a differential equation. Now we are moving for the second definition, which is important for our topic. So degree of a differential equation. So if degree of a differential equation is defining as a differential equation, so first this example, d cube y by dx cube plus sin x into dy by dx is equal to cos x into y. In this equation we defined the order of a differential equation is what, Nana? 3. So order of a differential equation is 3. So now this order as having the power is 1. So basically the definition of degree of a differential equation is the highest power of highest order differential coefficient is called degree of a differential coefficient. In this scenario, the example d cube y by dx cube plus sin x into dy by dx is equal to cos x into y. Its degree is 1 and order is 3. So for example, we are moving for second one, because of most of the problem if you have to go through for any competitive level exam, just like as okay, so any competitive level examination, so mostly a question is framing from order or degree of a differential equation. So now we have to see in that a differential equation. So d square y by dx square whole to the power of 3 plus 2 into dy by dx whole to the power of 4 plus 3xy equals to 0, or otherwise 3y equals to 0. For the sake of conveniency, I can take another example which may give a clear clarification regarding these two definitions. One is order of a differential equation and second one is degree of a differential equation. Now before we are finding this order and degree of a differential equation, is it a differential equation or not? So for this we are going to first one, this one having a ordinary derivatives, so ordinary differential coefficient. So we say that this is a ordinary differential equation. Now in this dy by dx is a first order differential coefficient and d square y by dx square is a second order differential coefficient. In this first and second one is more than, so means that simply this order is second order. Now we are moving for second order is having the power is 3 and the first order having the power is 4. Even though we are having the power 4, but we defined, okay namma, defined order of a differential equation. Order of a differential equation's highest power can be called as degree of a differential equation. Now what is the degree of this differential equation? So means that 3 is a degree of this differential equation. Sometimes we can find this type of questions, d square y by dx square whole to the power of 3 plus d cube y by dx cube whole to the power of 4 is equal to sin x into d to the power of 4y by dx to the power of 4. So is it a differential equation or not? Simply we say that as per our previous knowledge, this is a differential equation and this is ordinary, yes, because of it is having ordinary differential coefficients. So now in this we are having second order ordinary differential coefficient, third order ordinary differential coefficient and fourth order ordinary differential coefficient. So in the second order ordinary differential coefficient having power 3 and third order having power 4, but fourth order having only power 1. But however we can define this order is based on d to the power of 4y by dx to the power of 4 and its order is what, Nana? 4. So order having which power, Nana? Only 1. So means that the degree of differential equation is what? 1. Okay, na sir? So now we are moving for a equations which are having radical powers, means that under root of d square y by dx square plus dy by dx is equal to d square y by dx square whole to the power of 2. So this is also a differential equation, because of we simply say that a equation is said to be a differential equation if it is having a ordinary derivatives. In this equation we are having 3 ordinary differential coefficients, means that, but while we are finding or defining the order and degree of a differential equation. So order can be defining with respect to any condition, but degree must be defining by using the condition of the degree must be defining for the differential equation. Those the differential equation must be free of radicals and must be free of radicals and fractions. So here you have to see that at under root can be represented as d square y by dx square plus dy by dx whole to the power of 1 by 2 is equal d square y by dx square whole to the power of 2. If we are going for this, so d square y by dx square means second order differential coefficient, and dy by dx means first order differential coefficient, and d square y by dx square means second order differential coefficient. So means in equation we are having second order differential coefficient as twice, but if you have to see in that the second order differential equation having twice, even though its order is 2, but however we are moving for finding the degree of this equation, so must be the equation free of radicals. So here 1 by 2 must be free by using any kind of binary operation. So he is taking square on both sides, automatically then we are getting d square y by dx square plus dy by dx is equal to d square y by dx square whole to the power of 4. So now we are observing that it is also a differential equation, but however its order is 2. Earlier we are defining this, the order is 2. But if now we to define the degree, if you are moving for the d square y by dx square, order is 1, this degree is 1, dy by dx is 1, d square y by dx square is 4. So in this, so we can define this order of a differential equation, the coefficient d square y by dx square. So if we are moving for these, both of them same, but the degree is defined the highest power of highest differential coefficient order, means here the power 1 and here the power 4, so we can define the degree of this differential equation is 4.